In this video, we're going to cover Chapter 1, Section 1. Real quick, let's just identify the key skills for the unit. I can identify key features of various graphs, including domain, range, positive, negative, increasing, decreasing, intercepts, concavity, points of inflection, local mins and maxes, global mins and maxes, and symmetry. And we also want to calculate and compare average rates of change at a point or over an interval. Let's take a look at this first section, graphs and graphing utilities. We can review graphs and their functions, as well as use a calculator. The calculator we might do in class. So, Cartesian coordinate system. Remember, first quadrant is the upper right, then second, third, fourth. If you've always wondered why we kind of label these this way, we'll learn in trigonometry. In Precalculus, kind of the reasoning, one of the ideas behind this. The origin's in the middle, positive x values to the right, negative to the left, positive y values up, negative y values down. So when we plot a point, of course, we have our x coordinate and y coordinate. That means we imagine, or we start at the origin and we go 3 to the left, and then up to 5, and that's point A. Okay, now normally we don't make all these other marks, so just showing you here what that is. B, so we go 2, negative 4, there's our point B. C is 5, 0. If one of the coordinates are 0, then you're going to be on one of the axes. So because the y coordinate is 0, we're going to be on the x-axis here. D is negative 5, negative 3, so that ends up over here. 0, positive 4, so because the x-coordinate is 0, we are on the y-axis, and then f is 0, 0. A relationship between two quantities can be expressed as an equation in two variables, such as this. Now, y equals 4 minus x squared. I would like at this point to give a definition of solution, the value, or values, so I put that in parentheses, of a variable, or it could be variables, that make an equation true. So in this equation, let's see if 0, 3 will make this equation true. So I'm going to put 3 in for y, so 3 equals 4 minus 0. Is that equation true when I put the 0 in for x and the 3 in for y? No. So this is not a solution. Okay. Let's check another one. How about 3, negative 5? So I'm going to put negative 5 in for y. 4 minus 3 squared. Well, that's 4 minus 9, which does equal negative 5. So this is a solution. There are an infinite number of solutions to this equation, and the solutions will be in xy pairs. If we put all of these solutions on a graph, we will get the line. This is a parabola. Looks something like that. So the graph of an equation in two variables, this is what we just said, the set of all points whose coordinates satisfy the equation. So one method for graphing is the point plotting method, is to find points and graph this. So this is an excellent method. So I'm going to go select integers for x. Now, I do not want to do this method all the time. We need to identify other ways to graph and to sketch a graph quickly. So when x is 0, y is 4. When x is negative 1, remember we have 4 minus negative 1 squared, so that's 4 minus 1 is 3. 1 is going to be the same thing though, because it doesn't matter if I put a negative or positive in here. When I square it, I will get the same answer. And then we'll have 0, and then 3 we already did was -5. So we can plot these points here. -3 will be -5, -2 is 0, -1 is 3, and then 4, so 3, 0, -5. And then we draw those, connect those, and there is our graph. All right, example 3. So we're going to use the point plotting method again. We're going to graph y equals the absolute value of x. We don't have a ton of space here, so we're going to use part of this for example 3, and you can use part of this for checkpoint 3. So remember, the absolute value just means you find the distance between that value and 0 on a number line. So the negatives become positives and the positives stay positive. So my graph is going to look like that. Sorry, that didn't quite go through 5, 5. So that is the graph of the parent function of the absolute value. Graphing on our TI-84. We will cover this in class. You want to be familiar with all of these different features. You want to be comfortable with it. You want to be able to use them. It's going to be a great advantage to you if you are familiar. Intercepts. Intercepts are where the graph crosses the axes. Okay, so x-intercepts on our image here we see is where it crosses the x-axis there. The y-intercept is where it crosses the y-intercept. As we discussed before, the y-coordinate corresponding to an x-intercept is always 0. So this will be some value of x and 0. This x-intercept will be some value of x and 0. And the y-intercept will be 0 and some value of y. Okay, that helps us in finding the intercepts if we just have an equation. So example 5, identify the x and y intercepts. So the x-intercept is -1, 0, and the y-intercept is 0, 2. On B, the x-intercept is 3, 0, and there is no y-intercept. C, 0, 0 is both the x and y intercept. That's where it crosses both axes. And D, we have 2, 0, -2, 0. Those are the x-intercepts. And the y-intercept is 0, -3. Now, mostly a basic review, hopefully nothing too new for you today, but that'll get us started into this unit. Thank you for watching.